So hello everyone. So in this video, I'm going to tell you some interesting, excited feature which is implemented in MicroPython. So as you know that the MicroPython is a minimal version of Python programming language that is basically implemented for the microcontrollers. And recently, some of the popular microcontrollers support this MicroPython. That means directly you can run the tiny Python operating system inside the microcontroller itself. So one of such microcontroller is the recent Raspberry Pi Pico, that is 2040. So you can visit the official website of Raspberry Pi Pico, and the board looks like this one. It is basically Cortex M0 Plus series, which is having 1 MB RAM, and it's quite powerful compared to your Arduino Uno, and low cost also. And this Raspberry Pi Pico supports the MicroPython, and also you can program it by using that embedded C. But since the MicroPython belongs to the Python family, it's much more easier to implement program and to run it inside microcontroller. But while talking about MicroPython, and you know that since nowadays that embedded machine learning applications are gaining popularity. So when you are going for any machine learning projects targeting some microcontrollers, so you need to implement it in C. So because in MicroPython there are some limitations. The major limitation is in MicroPython there is no such array or matrix support. You know that in case of Python, the Numpy package do all the essential things regarding matrix operation. But unfortunately, till now in MicroPython, there is no such Numpy-like packages. So this is the major drawback, and without Numpy, you cannot go for any matrix operation. So whenever you are going to train any machine learning model, so you need to load the data set into some array or matrix. Okay, so this is the first basic requirement. So the MicroPython suffers from these main issues. So here I have developed one program which basically implements the matrix, which is basically the native Python list implementation. That means all the matrix and all the array basically implemented using Python list. And it is till now it is not optimized for speed, and some limitations are there. And in this video, I'll demonstrate a simple linear regression machine learning model, which will directly run from the embedded board, that is the MicroPython. In the Thonny, you know, it is one of the popular editor in the Windows platform, and also you can run it on Linux platform. So I'll show you how to implement a small linear regression model and how to implement it in MicroPython and how to run it. So let's start. So first, going to the basics, that means how our model is performing. So before that, I've implemented it in standard Python language using Numpy. So in this notebook, as you can see, that I have taken X and Y, some standard training data set, and the reshaping is done. Then from Sciki-Learn, that linear regression model is imported, and then fitting is done here. And let's go for prediction. So I'm giving some test data sheet, 5 data, and then the linear model predict these things. Okay. Now the same thing is implemented in the MicroPython environment. So first I've implemented it here without using any Numpy environment. So these are the built-in functions that are required for matrix operation and all these things. And so this is the function for the linear regression, and all these things are implemented here. And the main function, and I have taken the same input and just to compare the model performance. And as you can see, the X and Y value is same as before. So this one, okay. And for test also, I have taken the same. That means this data. So here the training is done, and that loss function is basically mean square error. I run it for 100 iteration, and I have taken the same test data set and I predicted the data, and you can see the result. It is coming like this. So you can compare this with the original Sciki-Learn model predicted result. So it is around 27, 74, 60, 37, and 83. And here also you can check it is 27, 74, 61, 38, and 83. It is coming same. So it indicates that whatever the functions implemented here, that is working properly. Okay, and it is totally designed using the Scratch and without help of any Numpy. Now coming to the Thonny implementation, now we are going to run it from hardware directly. So all the functions and all these things are written in form of a package, and it is already stored inside that hardware, that means the flash. So the same function which is present in the notebook, all these things are written here, and I just import it. I created a package of name PyLab. Okay, so import linear regression, and I have taken the same data for training purpose and the prediction, and then I've taken the same test input, and let's predict what is the output. So I'm going to run it. So as you can see, the iteration and all these things are going on here, and just take a look the command window. Okay, so it is the final result we are getting in the original hardware MicroPython environment. It is coming 26, 74, 60, 37, and 84, which is the same as our previous result, 27, 74, 60, 37, and 83.9 something. So it's working. Okay. So this is a very basic implementation, small steps toward the machine learning implemented in hardware without using embedded C. It's pure Python without using any Numpy. So you can use this algorithm to predict any values. Suppose you have connected a light sensor. So depending upon the sensor reading, you can convert it to ADC, it's a digital output. So depending upon the digital value, so you can predict the intensity of the light if you have previously trained your model like this. So here I have taken only one input. So similarly, you can take multiple input, but some modifications are required in this program. So you can do that easily, and you can build some linear regression model for multiple input feature. So that's all for today. So thank you for watching, and in near future, I will show you that how to implement some other machine learning algorithms such as logistic regression in this Thonny environment, that is MicroPython environment. Thank you.